Hello everyone, so I'll just come again with this topic electric field, which is from the chapter electric charges and field. So let's start this chapter for class 12th student. What is field? So like in the earlier knowledge, we saw that if we are just taking the earth, so earth attract a ball. Okay, that means any body earth will be start to attract because of this gravitational field. Okay, and now if we just take a magnet, so magnet will attract or repel the things. Reason is because of a magnetic field. Similarly, if we just take the few points about electric field, so what is electric field? If we just take in two type of charges, these are known as similar charges or like charges, so they will repel each other. If we just take another type of a charges which are opposite in the nature, so they will start to attract each other because of some field. So that field we are called as an electric field. This is because of electric field which is formed around the electric charges. For a positive charge, electric field will be radially outward. Okay. So now, if I'm just talking about the electric field intensity, so what is electric field intensity? Electric field intensity is a measure of the strength of an electric field. Every charge forms an electric field around it. So like a positive charge, as I told you, there will be a field which is radially outward. So electric intensity at particular point in an electric field is a force acting on the unit positive charge placed at that point. Means simple, if we just want to calculate how much intensity is that particular charge, so what we will take? Force per unit charge. If the value of force per unit charge is greater, that means the electric field intensity is greater for that particular scenario. That means E is equals to vector F by Q. Okay, so here Q naught we are taking, which is the test charge. Earlier we will see that particular thing. It is a vector quantity and the SI unit is for that Newton per Coulomb and volt per meter. So these things we already studied in the previous class, and the dimensions also, which is a Newton per Coulomb. By the help of that we can calculate. This will be ml t minus 3I minus 1. Now we are going and moving ahead with this main topic, which is the types of electric field. So we have different types of electric field. So electric field can be classified as a uniform electric field, non-uniform electric field, and radial electric field. The first one, uniform electric field. When the magnitude as well as the direction of electric field E, intensity at the same at all the points. In this particular criteria, we say that the field will be uniform electric field like this. Intensity at every point is same. That is called as a uniform electric field, which is a vector E. Now, non-uniform electric field. When the magnitude and direction of electric field intensity are different at different point of a field. As we can see that in this scenario, the electric field intensity or the magnitude and the direction are different in each scenarios. So we are saying this will be a non-uniform electric field. Next we have a radial electric field. So the field is the direction towards or away from the same point. This will be called as a radial electric field. Like if we just taken a point charge, so for a positive unit point charge, the field will be radially outward like this or radially inward. So this will be called as a radial electric field. Now electric field lines of a force. It is defined as a path described by a small positive charge placed in an electric field. The line of force due to the different charges are different. Let's see what are these. Like for the positive charge, electric field lines are radially outward. This will be for the isolated positive charge, and for the radially inward, this will be for the isolated negative charge. Now, if we just take in two similar or like charges, so as you can see, the electric field lines are start to repel each other. So a pair of like charges are like this, and pair of opposite like means unlike charges, so they will attract each other. So pair of unlike charges like this. So for a plane conductor carrying equal and opposite charges, for that electric field are uniform for that scenarios. Properties of electric lines of force. The first, they start from positive charge and end at the negative charge like this. Second, they always originate or terminate at an angle, right angle, to the surface of the charge. Third, they do not pass through a conductor. They never intersect each other. In case two lines of force intersect at a particular point, that means at that point electric field has a two direction or two tangent, which can't be possible. So two direction or two tangent. Which can't be possible. The relative closeness of a lines of force gives an idea about the relative strength of the electric field in the region, like this. So they have a more concentration, that means the strength will be high for that. There will be less concentration, so strength will be low. So they contract longitudinally, lengthwise, explains attraction, like this. If they are contract, then they will say as an attraction. And if they will start to repel, then what we are saying, okay, that will be saying as a repulsion, like this. So they exert lateral pressure on each other. This explains repulsion. Contract longitudinally, attraction. Lateral pressure, repulsion. Let's begin with this few questions so that we can understand what things we can grab in our mind. The electric line of force is the path followed by the free positive charge, negative charge, arbitrary charge, or zero charge. The correct answer for this question is option A, that is a positive charge. Next, which type of electric field is present in an isolated point charge? Radial, circular, elliptical, or hyperbolic? So for isolated point charge, we have a radial electric field. At which angle to the surface of the charge of the electric field lines or electric line of force always originate and terminate? 30 degree, 45 degree, 60 degree, or 90 degree? At which angle the surface of the charge of electric line of force always originate? The correct answer for that is a D, which is a 90. Electric dipole. So as the name is here, di means two, and pole, that means pole. So they have a two poles. Two equal and opposite charges separated by a finite distance forms a dipole. As you can see, this will be a two charges. One is a negative, another is a positive. If they are separated by a distance 12, then we will say as an electric dipole. There will be two particular points like an axial along the axis, equatorial, perpendicular to the given axis. So dipole moment P will be the product of the magnitude of any one charge and distance between them. That means Q into 12 in centimeter. This is a vector quantity and the direction starts from negative to positive. Okay. If I'm just talking about the dimensional formula, so this will be LTI. Torque acting on a electric dipole in a uniform electric field. So in this particular topic, like we have taken a different types of dipoles. Different types of a dipoles means we have taken like two different kind of a charges over there, which is separated by a distance 12, and they have a uniform electric field, which is a vector E, which is start from positive to negative. Because of that, a charge plus Q feels some force of attraction towards a negative charge, and negative of a charge Q feels same attraction towards a positive charge. Because of that, they will start to tilt and they feel some torque for that. So torque will be force into perpendicular distance. Force will be what? F, and the perpendicular distance is a component of a 2L. So this will be what? 2L sine theta. Okay, so AC will be what? We can calculate this AC. F is equals to QE, and AC will be, we can calculate from here, sine theta is equals to AC divided by 2L. So AC is equals to 2L sine theta. We just put this value over there and get the value of a tau, which is a 2L QE sine theta. So we can get P is equals to Q into 2L, that means PE sine theta. Maximum where the theta is equals to 90, theta is equals to P cross E, because sine 90 is equals to 1, and minimum when theta is equals to 0, because that time torque will be 0. So this is the final value in the form of vector. Vector tau is equals to vector P cross vector E. Let's start with some MCQ question. Like the first one is, the magnitude of a torque acting on a dipole is a maximum when the angle is A 30, B 45, C 60 and D 90. So this is the case for maximum. So in the case of maximum, we are taking 90 degree angle. Second, which type of a quantity is a dipole, electric dipole moment have? Scalar, vector, tensor, or none of these. The correct answer for this question is a B, which is a vector quantity. Electric flux. So electric flux is a nothing but the total field lines of force passing normally through a given area. Like we have it taken, for example, I just want to elaborate this thing a very clear way. Like if we just taken a particular like this is the electric field lines which is uniform, and supposing this will be the 100 field lines, and if this will pass through a small window, so is there every line passed through this particular window? Answer is a no. Only few lines which is a came across this section. So only few lines, and supposing this will be 40. So this 40 will be the electric flux and remaining will be the electric field lines. Okay. Again, the total number of field lines of force passing through normally through the given area. This will be the area, and as you can see, this will be the perpendicular section where the field lines are passing. Clear? So if I am supposing this is a vector E, which is a passing through the surface ds, so d phi will be that ds, which is a making angle theta, so the component of theta will be e cos theta. That means d phi is equals to e ds cos theta, or d phi is equals to vector e dot vector ds. For a uniform electric field, electric flux throughout the plane surface, phi is equals to close integration d phi, or phi is equals to integration of a vector e dot vector ds, which is a vector e dot vector s. So es cos theta. Let's begin with the sum question. Electric flux is defined as the number of field lines of force passing through the surface, passing dash through the surface, normally for parallel at 60, at 30. So the correct answer for that one is option A, which is a normally. Second, electric flux is an elementary area defined as a product of area and electric field. Vector, scalar, tensor, none of these. The correct answer for this question is a scalar quantity. So thank you for watching. Soon we will come with a new topic for the board exam. Till that, bye-bye, take care.